So last week we got to talk about sine and cosine and how they relate to a circle instead of just a right triangle. And we talked about how the angle that we have traveled around the circle is still associated with the right triangle. And so we can designate sine and cosine values for all of those angles as you spin around the circle. And this was designated as the sine function and the cosine function. And so now we want to talk about what does the graph of the sine function and the cosine function look like? What is that effect for the sine and the cosine? And we also want to talk about, what is that still in relationship to the circle, even though we're talking about a graph. If you recall, sine and cosine came from wherever you were on the circle. You got this right triangle. And we discussed that the cosine value actually ended up being the x-coordinate of that point. And the sine value ended up being the y-coordinate of that point. And so we kind of got used to this being the point that we're talking about. But this point on the circle is not the point that gets graphed when we talk about the sine and cosine function. Because remember, functions have an input and an output. So if we think about the sine and cosine functions, for sine and cosine both, the input is the angle that we're talking about. Remember, we always had this associated with an angle. So what is the sine of pi over 6? Or the sine of pi over 4? The sine of 60 degrees or 180 degrees, the input is the angle of the function. So that's our input, our x value of the function. The output of the function was either the x or y value of the circle on this point. So for the cosine function, it was the x value of this point. For the sine function, it was the y value of this point. And so when we talk about the sine and cosine function, realistically, we're always modeling something that is spinning around a circle, all right? And the input is the angle that it is on that circle. Where is it on that circle? And the output is the sine or the cosine value for that angle. So what does that actually look like as a function? So we're going to come over here and look at a model. So here we have a circle, and it's the unit circle. Notice that its radius is 1. So it goes up 1, down 1, back 1. So this is a circle of radius 1. So this left-hand side is showing us spinning around the circle. On the right-hand side of the graph here, we're going to actually plot the sine values. Let's look at the sine values first. Now, if you recall, sine was the y-coordinate on the circle, correct? So up here, if I change the angle that I'm spinning around the circle, so right now I'm at 0 degrees, and sine has a 0 value at 0 degrees. But we can keep moving, and if I get up here to 30 degrees, notice that what we're doing over here is tracking how high are we on the circle. What is that y value? What is the height on the circle? And we're just going to spin around the circle. So here we get to the top of the circle. That's as high as we get on the circle. And this is where we start to come down on the circle. So we come down, we come down, we come down. When we get at 180 degrees, we're back where we started at that 0 height. And we're still dropping. And then we get to the lowest point on the circle. And we actually start coming back up again. And then we get to 360 and we're back to 0 again. So what you notice is as we spin around the circle, we create a wave. So sine and cosine functions are actually waves. It goes up the circle as we spin, then we come back down the circle, we're back to the middle, and then we go down, and then we come back to where we started, and we have made one full cycle around the circle. So sine is modeling my height on the circle, my y value on the circle. And we know that cosine is modeling the x value. So it's kind of like, where am I left to right on the circle? So this time we're going to look at cosine as we spin around the circle. So if we spin around the circle, notice that we started at 0, but at 0, cosine is actually equal to 1. So as we're going up the circle this way, our x distance is getting smaller, and now it's at 0, and then we come back around here and we're out to -1. So now it's down to the bottom. Then we come back to 0, and then we go out to +1. Now, when we do sine, we started in the middle and we went up to the highest point, back down to the middle, down to the lowest point, and then back up to the middle. So I want you to notice sine starts in the middle, goes up, comes back down to the middle, goes down, and then comes back up. Cosine actually starts at its highest value. It starts at 1, then it drops down to 0, keeps dropping down to -1, comes back to 0, and then goes back up to 1. Sine and cosine are actually the exact same shaped graph. They have the exact same shape. Notice it's a wave. And in fact, they continue. If you continue on, it goes around and around and around, and it can just keep going. And it continues on and on and on and on, and it's a continuous wave. So that's also important to note that sine and cosine functions are what we call periodic functions. They repeat. They're the same thing, continued on and on and on. The sine graph is this piece of a graph repeated over and over and over again, because here it's just going to keep going up and then keep going down. Over here it's still going even, because we know we can spin in the circle in negative direction. We can go past 360 degrees. That's why it was important for us that we could keep spinning around the circle. It's a function, it's continuous, it keeps going, but it's repetitive. We're just bouncing between 1 and -1. And all of the values that are between 1 and -1. So sine starts in the middle, goes up, goes down to the bottom, and then comes back up to the middle. One cycle or one trip around the circle is what we call the period of the function. That is one period of the function, thus periodic. All right, and cosine, one period for cosine. Cosine starts, because we always start over here on the x-axis, remember, and we spin counterclockwise around the circle. Cosine starts actually at its highest value. So it starts at the maximum up here at the top, dives all the way down to the minimum down at the bottom, and then it comes back up and ends where it started at the maximum. So just like all functions, there are a maximum and a minimum for the sine and cosine function. Our circle has a maximum and a minimum. It's just bouncing between those two values. We do have a couple of names for the parts of these graphs, so let's talk about those real quick. We've got this middle point. You know, the circle has a middle. There's the middle of it for sine. You know, it's the x-axis is the middle for sine. And for cosine on the circle here, this y-axis is the middle, and it's always bouncing around that middle. And we call this the midline. You know, very boring, very self-explanatory. It's the midline. That's what we're bouncing between, right? Or bouncing around, I guess we should say. So it's very important to note that sine starts on the midline. That's its starting point for its basic graph. Cosine starts on the maximum. And that's very important to remember because it's the only difference between sine and cosine. Sine and cosine are both the exact same shape. They're bouncing. They're waves. Sine just happens to be bouncing between these on the circle, and cosine happens to be bouncing between these on the circle. But the effect that has on the shape of the graph is the exact same thing. So sine and cosine have the exact same shapes, the exact same parts to their graph. The only difference between the two is where on the wave do they start. Sine starts in the middle, goes up, comes back down, and then goes back to where it started at the middle. Cosine starts at the top of a wave, falls all the way to the bottom, and then comes all the way back up to the top. So it's very important to realize they're the exact same shape. The only difference is where do they start. Now, other important vocabulary words and things that we need to know when we are graphing sine and cosine. You want to know where the midline is because that's where you're bouncing around. The other thing you need to know is how much are you bouncing? How far up do I go? How far down do I go? If we think about our circle here, we're bounded by the circle, okay? It's the radius of the circle that tells us how high I can go and how low I can go, how far to the right I can go, and how far to the left I can go. And so we just bounce between whatever the radius allows us to go. So from the midline is always wherever the center of the circle is. So important things to remember. When we're doing this function, we always want to relate the function to what's actually happening on our circle, because you have to realize we use these to model things that have a cyclic nature, things that happen in cycles, things that happen in waves. And so we always want to make sure we're associating what's going on with this over here. So we want to realize that as high as I can go, or as low as I can go, is always based on the radius of the circle. Now, we don't call it the radius on the wave. In fact, if you've studied waves in science, you may know that the height of a wave is called the amplitude. So the amplitude is how high above the midline can I go and how low below the midline can I go. And we know that in the circle, that's actually the radius of the circle. The midline is always where the center of the circle is. So the center of our circle, wherever the center of the circle happens to be, that gives us our midline, and I can bounce above and below the midline, or I can bounce to the right and to the left of the midline, and that's what gives us our waves. So the center of the circle determines where our midline is. The radius of the circle determines our amplitude. Whether it's sine or cosine determines where on the wave I start. And the only other thing we need to know is the period. How long is the wave? How long is the wave? And the period is one full cycle around the circle. So it depends on whether you're doing degrees or radians, but if you're doing degrees, one full cycle is 360 degrees. If you're doing radians, remember one full cycle is 2 pi degrees. So when you're doing a wave and when you're graphing it, we always want to know what is that period, because that's one wave. Everything's just going to be repeated after that. So I always mark off, okay, 0 to 2 pi. That's one full wave. And basically every wave is broken up into 4 pieces. There's a halfway point, and then you've got your halfway between the halfway points. So I always take my whole period and I break it up into 1, 2, 3, 4 equal pieces. And when you do that, you can draw all 4 points of your wave, because I know that if it's sine, at the first stop where I'm starting, I'm in the middle. By the first fourth, I should be at my maximum, 90 degrees around, I'm already to the top of the circle. Another fourth, I'm back in the middle because I've made it over here. Another fourth, I'm down at the bottom. And the last fourth, I'm back where I started. If I'm doing cosine, when I mark the period and break it into fourths, I know for cosine, I want to start at my maximum, which is the amplitude, and then I want to come down, and I'll be halfway down. Halfway, I'm at the bottom. The next fourth, I'm back at the middle, and then I end back at the top again. And that gives me enough points that I can draw a nice, good wave. So I know where that information comes from the circle. What does that look like in the equation? All right, so let's say that we want to graph y equals 2 times sine of x plus 1. So let's think about, we know what the parts to the graph have to be. We have to have the midline. We have to have an amplitude, because that tells me how far above and below the midline I'm going to go. We have to have a period, because we need to know where each one of these waves is starting and stopping, so forth and so on. And I have to know where I'm starting my graph. So we know that everything's going to kind of revolve around the midline. Where's the center of that circle? It should be at 0. But we also know that we can transform our graphs. And so sometimes it gets shifted up or down. And if we look at this graph, it got shifted up. And so that means that my midline, instead of being at 0, is going to be at 1. So I'm going to give myself a little mark here at 1. Now again, the midline doesn't show up in the graph, so notice I'm using just yellow. But I need to know where's the middle of my wave. So I'm putting a midline there. And so big thing to note is if you've got anything added outside of the function, this is always what shifts our graph up and down. This is always going to give you your midline. It's where the center of the circle is. Now, I do notice that it is sine. So sine tells me that I'm going to start on the midline. I'm not starting at the maximum, I'm starting in the middle. So I know that my graph is going to start right there on the midline. There's my first start. Now, a period, we said, was 1 full rotation around the circle. So looking at my x-axis here, it definitely looks like it is marked in degrees. So since it's marked in degrees, I know that 1 full rotation around the circle is 360 degrees. So 360 degrees is right here. So I know that sine starts and ends right there on the midline. So now I want to break it up into 4 equal pieces. 360 broken up into 4 equal pieces. You don't even have to really get that accurate in your math. When I look at this, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 of these lines. 12 divided by 4 is 3. So if I break this up into, groups of 3, you're just physically looking at it and breaking it up into 4 equal pieces. And so I know sine starts in the middle and it goes up. Then it comes, so at up. So at this first one, it's going to be at its maximum point. Then it's going to come down, so it's back at the middle. Then it's got to be at its minimum point, and then it's going to come up to the top. Now, I do need to know my amplitude. How far up and how far down is it going? Again, we know the default is the unit circle. It has a radius of 1. But I also know how transformations of graphs work. And I know that this is going to be a dilation. In fact, it's going to stretch it up and down. And so because this number is a dilation, this number out here becomes our amplitude. And so when I'm looking at these equations, if there's anything added or subtracted out here, that's changing where my midline goes. Any number being multiplied out here, it's changing the radius of my circle. So that means that when I go up to my maximum, instead of going up 1, I'm actually going to go up 2 spaces. Then I come back down to the middle. Then I've got to go down 2 spaces. And then I come back up to the middle. And so I get a wave that looks like this. Now, we also want to point out that it keeps going. So, you need arrows. But most of the time, you want to at least graph one full period. And honestly, you should fit 2 or 3 if 2 or 3 will fit on your graph paper. It just depends on the problem. But this is the process that we go through. We look at the equation, and we have to answer these 4 questions. Where's the midline? What is its amplitude? What is its period? And where does it start? And then it's just a matter of tracing out your wave. The only difference between sine and cosine is where they start. How you find the midline, it's always going to be that number that's added or subtracted outside. How you find your amplitude, it's always going to be a number that's multiplied by the front. How you find the period, it's always one full rotation around the circle. The only difference between sine and cosine is whether you start in the middle of the wave or do you start at the top of the wave.